Hey guys, welcome back to my YouTube channel. So in this lecture, we are going to continue our discussion on the PN junction. So in this last class, we have mostly discussed on the charge carrier concentration, like how the charge carrier concentration levels will vary. Like this is the slide that we followed, right? So here there is no charge carrier changes. So we have represented that traces the boundary, and then there is some small increase in the change in profile, like how we say there is a depletion region. So at this point, there will be max of the without the charge carrier, no free charge carriers will be there. So there will be full of donor atoms, acceptor atom in the p type, and full of donor atoms in the n type. So this we also made approximation, the depletion approximation for our analyzing purpose. So I will know how we can analyze all those things. So now let's take charge density analysis is done. So now let's get into the analysis of electric field. So we know that there will be some inbuilt electric field that will be developed because of the diffusion of charge carriers from positive to negative. So let we draw the electrical field, that how it will go. Electric field will trace the boundary here, and eventually at this region electric field will be max. So it will be going to this, and then again it will go into this region. So it will be max at the E is equal to 0, and then again it will traces the boundary because there is no internal electric field is here. So make of this, so at x is equal to 0, the electric field which there, right, so which is E naught, so which is the max. So let's draw the voltage curve. So the differentiation, the integral negative of the electric field, which will be the voltage, right? So if we integrate this region, the area will be keep on increasing because the integration which will be taking only for positive charges. So the voltage will be starting at the traces of boundary, and then it will be eventually increasing, and it will be sustaining after this one, because once it is going back, the area will not decrease, because we are taking, we will be tracing modulus only positive things. Yes, even for negative we will be consider that as a positive only. So at this region, after this, the electric field will be, so the voltage can be, up to this it will be 0, the voltage will be internal voltage, built-in voltage will be 0. After that it will be increasing at that point, then it will be traces, no increase. So at this point it will be v naught, the max will be v naught. So this entire gap that we can represent as the v naught. So this will be v naught. Okay, so I will be letting know to calculate how, what is the v naught and what are the value of v naught in the upcoming lectures. So this is xn and this is xp. Okay, so this is how we can draw electric field and voltage curve, so which is v of x and which is e of x. Okay, I hope it's understood, right? So how we are drawn is the charge carrier, whenever, because of this electrical field changes, the electrical field will be keep on increasing, and then it will back to 0. So that is what the coincidence. So at this point the electric field will be maximum, and the we know the voltage curve, how to find the voltage value is that we need to differentiate, integrate this region. So if we integrate this region, the area will be keep on increasing. So we, up to this region the area will increase, after that it will be getting constant. So this is how the voltage curve will be written. So in this upcoming lecture, I will be letting you know how we can calculate the individual E naught, V naught, everything. So for now I will be giving you the formula. So in the next lecture I will be matching all things. So E naught max, which will be equal to QNA XP divided by epsilon, or also minus Q ND XN divided by epsilon. The minus indicates that is a negative region. Okay, and then the voltage V naught, built-in voltage, will be VT ln Na Nd divided by Ni square. So these two formulas, how to find out this one, I will be letting know. So no worries in that. So in this upcoming series of lecture, I will be teaching how to get those values. So for now, you guys know this is how we can draw the diagrams. So from P to N, if the PN junction is drawn, the voltage, the electric field will be negative maximum. If NP, the polarity is reverse, then the electric field will be in this direction. So then it will be in upper curve. So because that is here it is negative, right? So it will be keep on decreasing the electric field and then increasing because of this positive charge carrier. But if it is reversed, then it will be positive and negative in case of an NP. Then it will be going to upper trace and then it will go down. So that is what some quite difference that you have to learn. So I will be letting know that thing also in the later thing. So this V naught can be called as many term, that is built-in potential, contact potential, barrier potential, diffusion potential, depletion potential, open circuit potential. Many different names are there. So this is another very important terminology. The 0.7 we say, right, the diode VD built in the voltage, the cutoff voltage. That is because of this only. So these things will be correlating more in the upcoming lectures. So I will know how we can do those things. So for now, let's see if a forward bias is applied to a PN junction, then what will happen? Forward bias. So if the PN junction is connected with the forward bias, we know that the depletion region will be decreasing. Why the depletion region will decrease is that the more number of charge carriers will be injected into this one by external force. So let me draw a diagram so that you guys will be able to understand it clearly. Okay. So let's apply. Let's take the PN junction diode. So this is the region of separation. This is P and this is N. Okay. So it is positive and this is negative. When positive is connected to P and negative is connected to N, then that is what the forward bias. If it is a reverse the polarity, then that is reverse bias. Okay. So let's draw the depletion region also here. So let's take the depletion region also. Okay. So this is the depletion region. So let me add this in next page also to analyze the drifting potentials. Okay. So this is for forward bias, right? So let me draw the charge carrier things. So here it will be negative and holes will be presented here. Here the holes will be removed as it will be diffused to this region before itself. Okay, 0. So here positive, as there is no hole, there won't be any holes. Okay, because there is a depletion region. So positive, this is donor atom without free carriers. There will be donor atom with the free electrons. Okay. So because of this, some internal electric field that will be developed. So that is E internal. Okay. So because of the external supply to positive to negative, there will be a greater electric field. The electric potential that develop will be greater than the internal electric field. So this is E external that is got developed because of this battery voltage source. So then what will happen? The more number of holes will be pumped to this side. What will happen? More number of holes will go this way. The whole number of holes because of external battery supply. So it will come here. More number of holes will come here. Will again fill this region, and the more holes will be pumped. So that holes will be passed to this side also. This will be diffused to this side, and holes will diffuse, and then it will neutralize this region, and then it will go. Then here more number of electrons will be going to this side. More number of electrons will be pumped to this side. It will come here. It will come and it will diffuse to this side, and it will again diffuse to this side, and it will neutralize these holes. Similarly, it will neutralize these holes, then the new hole will be created here. That will be again neutralized. So that there will be movement of charge carrier. So this is what they are saying as the current. So you see the holes moving this side and electrons moving this side, right? So that is what the current movement. Then what will happen? This depletion region will be nullified. So if it is forward region, this depletion region will be decreased, much decreased. Even it won't exist. So this potential barrier will be removed. As you, I think you guys able to get it right. So depletion region will reduce, and the holes will be traversing from P to N region because of the external supply, and electrons will traverse from N to P region because of this external supply. Then what will happen? Then there will be the dP by dx profile will be keep on increasing. The charge carrier will be keep on increasing because of the external and internal electric field. The internal electric field which will be nullified because of the much greater external electric field. So then there will be the I net will not be equal to 0. I well will not be equal to 0. There will be some current movement because of the external battery supply that we have produced. I hope you guys able to get it right. So the I net will be because of two things, both because of minority and majority charge carriers. That will be IP plus as well as IN. because here you see the holes are moving to this side and electrons from here are moving to this side. So this will cause a because of this the net current IP will be this, right? Electrons is moving, the opposite direction will be the current movement of current, so IP. So both are aligned to this direction, so current will flow from this. So the current will flow from positive to negative terminal, so that is what the I net. Okay, so this is what I net. So I net will flow from positive to negative terminal because of the charge carrier movement. So I hope you guys able to understood, right? So this is how the current movement will be observed. The current can be also stated in another one function, that is I, which is equal to I naught e power V divided by eta Vt minus 1. This is diode voltage, diode current equation. So diode current equation that even in the further lecture we will be deriving this one also. So for now you guys know the current movement and the current can be equated by this equation. So this is how the forward bias PN junction holes are injected electrically from P to N side and electrons are injected from N to P side. Since the injection holes are majority charge carrier, hence the injected holes are minority charge carrier in N region. Hence there will be recombination with electron. Concentration goes on decreasing. So you guys need to understand this. Since the injected holes from P to N region, holes will be injected, right? So that will be minority charge carrier. So that will be minority charge carrier. Okay, minority charge carrier inside. Hence, there will be a recombination with electron. So electrons present here, right? So plenty of electrons will be free electrons will be there, right? So that will be recombined, and there the concentration goes on decreasing. The injected holes concentration will decrease. Okay. Then similarly, the injected electron from N to P region is also minority charge carrier that will recombine with the holes in this side. So that concentration will also be keep on decreasing. Okay, since the external potential that is opposing the internal potential, hence net depletion region will decrease further. Okay, since holes are traveling from P to N, hence the depletion ions on P region may break their lost charge carriers and become neutral. Okay, so in the depletion region it will become the charge carrier, it will retain its charge carrier, so that the depletion region will further decrease and then it will letting the current to go. So I hope this will give you some theoretical understanding of how the current flows will work. Even this is not the practical way. In the diagrammatic representation we have seen, right? So because of this external supply, the holes will be injected from P to N and it will recombine with the electrons here. So there is movement of charge carrier from one region to another region, and similarly the electron will move from this region to this region. As the charge carriers are recombined, further more charge carriers will come and that will be also recombined with electron. So these recombination will make further movements of electron only, right? So the electron movement will not decrease because that will be recombined. So it will expect more number of magnetic charge carrier to recombine. So this movement will be further produced and more number of current movement will happen throughout this device. So this is how the current is happening. So diode is not contributing current. So diode is the PN junction diode which is making the movement of current. So there is some kind of application like switch that it can add, and BJT plenty of application is there. So those things we will be seeing. So diode is not a magical box, or even BJT is not a magical box. So we can use this application in any kind of things, like in BJT we use that for amplifier, right? So I will let you know how we can boost the AC signal with the help of DC signal. So these kind of applications are much needed, and that is what the expected behavior there. So I hope the forward bias operation that you guys able to understand. If you guys have any doubt, please ping in the comment section. I will post it. The post I will clear that out. So like, share and subscribe channel. Stay tuned for more lectures like this.